We have left last video with our happy bouncing ball bouncing and bouncing. But now I'd like it to move forward a bit. So let's do that together. The first thing I will do is to press 3 on my numpad to switch to side view. Now, instead of making my animation loop over 24 frames, I'd like to make the animation a little bit longer. So I will reopen my timeline and I'd like to repeat the animation 4 times. So I can type in 4 times 24 frames to get to the right frame number. But the problem is that my bouncing ball animation is not repeating over those 96 frames. So the more logical method to make it repeat will be to select all my keyframes, duplicate them by pressing Shift-D, X to move them on the X-axis, and type in 24 so that they will be moved by 24 frames on the X-axis. Then I can press Shift-R to repeat the operation. The problem with this method is that if we have any modification to be added to the animation, we will have to reduplicate everything or modify it on each bounce. While it's not super painful on such a simple animation duplicated only 4 times, this is not an efficient way to do it. So I will reset what I've done, and with all my keys and curves selected, I will press Shift-E to open the keyframe extrapolation menu. By default, our keyframe extrapolation is set to constant. It means that whenever I reach the very last keyframe in my animation, the value won't be changing anymore. That's why we get flat curve. But judging by this extrapolation menu, we can see that we can switch it to linear extrapolation or even make a cycle. You can also access the extrapolation operation through the channel panel in the header of the graph editor. With all the curves selected, let's choose Make Cyclic. Boom, our animation is now cycling infinitely on the timeline. And the cool thing about using extrapolation is that modifying our animation will be repeated and updating along the whole timeline. With this problem fixed, I'd like my ball to move forward in space. So I'd like to animate the y-axis of the ball. So I will insert a single keyframe on the y-axis, go to frame 24, move the ball by about 9 meters, go back onto the transform channel, right click and insert a single keyframe. If I now play the animation, the ball will move forward only on the keyframe we have inserted. And since Blender is creating by default a new keyframe with the Bezier mode, we have an acceleration and a deceleration of the ball that doesn't look super natural. While this kind of locomotion could be a little more complex, we will consider that our ball is moving at a constant speed. So I will select both handles, press the V key and switch them to vector. You could have chosen to press the T key and switch to linear interpolation, but I prefer to use vector interpolation to keep the handles available. When I watch this motion, I feel like the ball should move a little further. So I can take my last control point and move it a bit upward, or insert a new value in the transform channel and don't forget to insert a keyframe. Or we can directly change the value of the keyframe by going into the F-curve properties and enter 10 meters in the value of the keyframe. This is a good method when you want to enter very precise values. Now I'd like my ball to continue moving on each bounce. So I could duplicate last keyframe, offset it, or insert a new keyframe and set it to 20 meters. But again, if we want to modify the timing of our animation, making the jump a bit longer, I will have to modify those two. And on a more complex animation, that will be very painful. So let's get rid of this and find another solution. If we go back to the extrapolation menu, we will find an option that allows us to create a linear extrapolation. Blender will take the last 2 keyframes of an animation and it will do an extrapolation based on the value differences between those two. So that's a great step forward in our animation. But there is something that bothers me. When our ball hits the ground, it stays on the ground for a few frames. The problem is that it's sliding currently and it doesn't look good. I'd like the ball to stay where it is when it's on the ground and move forward whenever it's airball. To fix it, I can simply duplicate the very first frame and move it on frame 3. But I need this new motion to repeat along the full animation. So I will press Shift E and choose constant extrapolation to get rid of the linear extrapolation. But now my animation is no longer repeating, and whenever I'm re-adding a linear extrapolation, it will just continue on moving instead of stopping whenever the ball is contacting the ground. So I can try using a cyclic extrapolation, but the problem is that the ball will get back to its original position after each cycle. So I'd like it to cycle but with an offset. And what we can do is select one of the keys of the curve and go to the modifier tabs here. And we can add a cycles modifier. So it works exactly as if we were adding the cyclic extrapolation, but we do now have option on the cycle behavior. I can change the way it acts before and after the cycle. So if I go onto the after, I can ask Blender to use the repeat with offset. And what it does is that it takes the very last keyframe and use it as a new starting point. So offsetting the animation is currently adding it on top of the latest keyframe. An extra motion is missing though. If we watch this video, you'll find the link in the resources PDF. I'd like you to focus on the body shape and orientation of these links. During this gorgeous motion, we can see the squashing and stretching, but we can also see some rotation of the body. The body in the beginning is oriented toward the up point and then oriented toward the landing point. So we do need to input those information on our bouncing ball. To get a better preview of the motion of the ball, I will calculate the motion path. As seen in the previous video, I will go into the object option, motion path, and click calculate the path. I will change the path type to in range and change the end frame to 96. This will give us the motion path of our ball, and it's going to be easier for us to figure out how much we have to rotate it. The idea is to simply rotate the ball toward its next position or its next frame position. And once we have passed the highest point, we will make the ball pointing toward the previous frame. Since our first frame is exactly the same as the latest frame, or frame 24, I will jump to frame 24 and give the correct orientation to the ball. It seems that 11 degrees looks fine. Then I will right-click and insert a single keyframe. A new channel has appeared in the graph editor. It's our X Euler rotation. So I will now go back to the frame where the ball is currently leaving the ground and rotate it by minus 12.5 degrees toward its next position. So now, as we have did before, I will duplicate the last frame, frame 24 of this Euler rotation, and move it onto frame 0, pressing Shift D, X, and moving it with the mouse. Now that the initial frame 0 and final frame 24 are the same, I can select my curve and press Shift E and make it cyclic. And it already looks pretty cool. So while the motion I'm seeing right now is pretty satisfying, you know that we need to check it frame by frame. As any craft, a perfect animation doesn't exist, and the level of quality you will reach depends on the time you can spend on your animation. In this case, I'd like to polish the animation a little more by making frame number 1 pretty flat. because I don't really like the fact that the ball is slightly leaning backward when it's getting in its flattest position. In the graph editor with the X Euler rotation curve selected, I will press I to insert a new keyframe and choose Only Selective. This way Blender won't add any additional keyframes on the other curves and our graph editor will remain clean. Then I can grab this key, move it on the Y-axis holding Shift to get a more precise movement. And I will call this first bouncing ball animation done. The technique we have used in this video, adding a rotation motion based on the location motion, the up and down motion of the ball, is called the layered approach. It means that you add layers and layers of motion during the polishing stage, not during the blocking stage. And we'll study this technique more in depth later on. To summarize, we have seen that we can create cycles using the Shift-E shortcut and choose different extrapolation. We can access more advanced cycle options using modifiers. We can use current motion of the ball as the guide to add new motion to it in a layered approach.